Okay, now for a look at the expectation and variance of a binomial distribution. Both of these are given to you in your formula booklets, so I might just bring that up now. Okay, here's the relevant page from your formula booklet. You can see here in 5.7 the expected value of a discrete random variable. We looked at those in class. That was in exercise 15b, where you just took the sum of the random variable times its probability, so x by the probability of it, and you sum those up. That was the expected value across a range of random variables. Just to get the word out. All right, now in 5.8 you can see what we're doing now. The binomial distribution, my last video, and that's just here for you. So you can see here that x is binomially distributed, where n is the number of trials, p is the probability of success. Then this is the calculation here, NCR by the probability of success to the power of r. R is the number of successes, remember. 1 minus p being the chance of failure, to the n minus r. So that's there for you. Now what we're looking at in this screencast is mean and variance, or mean is another way of talking about the mean is the expected value. And you can see that's what we were looking at yesterday as well. But now we're looking at it for the expected value of or the expectation of a binomial distribution. That's just equal to NP, where n's the number of trials and p is the probability of success. That's pretty logical information. And the variance also, which is calculated, the variance of the random variable x will be NP by 1 minus p. So let's have a look at how that plays out. Let's think about that example where the student was guessing all 10 multiple choice questions. So with reference to the student guess, the 10 multiple choice questions with 5 options on each, with reference to that, so the probability of success was equal to 0.2 or 1/5, and the number of trials was 10, and it is a binomial situation because there are only 2 options, they are independent of each other, and there are a limited number of trials. So this is, if this is random variable x, it's binomially distributed with 10 trials and a 0.2 probability of success. Now if we wanted to establish now therefore what the expected value, so therefore the expected value of x we know now to be NP. In this case, it's apply logic. How many would you expect the student to get correct? If they're guessing, they're going to get 1 in 5 correct. They should do. If they do, if we took 1,000 students guessing, that's how it would work out. So some are going to get lucky, some are going to get unlucky, but we would expect them to get 1 in 5 right. So if there are 10 questions, we'd expect them to get 2 right. And surely that's completely logical. So 10 times 0.2, which of course equals 2. So the expected number of successes in 10 trials when the probability of success is 1/5 would be 2. Absolutely logical. The variance, now the variance is how much would we expect it to vary from 2? Just like we've looked at before with these things. Now standard deviation is a measure of spread. Variance is the square of the standard deviation. Now the variance is equal to NP by 1 minus P. So this is 10 by 0.2 by 0.8, which in this case is, what's that? 2 by 0.8, which is 1.6. So the variance of the random variable x in this situation will be 1.6. Therefore, we're often asked for the standard deviation. The standard deviation is equal to the square root of 1.6, which equals, right, so to go away and calculate that, that's 1.26 to 3 significant figures. So we've got an expectation of 2 and a standard deviation, which if you remember on a normal distribution, which we're going to look at next actually, we're looking at one standard deviation either side of the expected value or the mean will account for nearly 70% of scores. So that's 1.26. You can put that in context with the mean score of 2. So between 0.74 and how am I going there? Yeah, 0.74 and 3.26. We would expect most of the scores to lie. It's about 70% of the scores, in fact. Okay, so that's it really for expected value or mean value and the variance on the binomially distributed where probability of success is given, and we've got a fixed number of trials. Fairly straightforward, and you can see, I'll go back in there and have a look at the formula booklet. There it is, expected value NP, variance NP, 1 minus P. It's all there for you, so can't really go wrong. Excellent. So we're now good to go with. Okay, I just cut myself off. So we're now good to go with exercises 15F. And I think 15G also, and that brings us up to the next section on the normal distribution, which is not the discrete random variable, but the continuous random variable, and we'll get into that in due course. All right, see you soon.